Hi everyone. So now we're going to do a little bit more work with z-scores and actually look at some applications there as well. There are actually a lot of applications with z-scores, so we're just touching on really the tip of the iceberg here with some of the work that we can do with them. So here you have table 12.16, which gives you z-scores along with their percentiles. So you'll notice you have 4 columns here, and this does actually get longer if you kind of scroll down to the rest of the worksheet. And you have all your z-scores here. I shouldn't say all of them, but a lot of the most common z-scores here. And then you also have the percentiles given in the right column. So this is what we're going to use in this section. So the above table can be used to find the percentage of data items that are less than any data item in a normal distribution. So key is that it's less than. We're going to begin by converting the data item to a z-score, and then we're going to use the table to find the percentile for this z-score. That percentile is the percent of data items that are less than the data item in question, so what we're focusing on. And I think this will make more sense once we actually see an example. Right, so I'm just going to put the table off to the side for a moment. So according to the Department of Health and Education, cholesterol levels are normally distributed for men between 18 and 24 years, and the mean is 178.1. This is measured in milligrams per 100 milliliters. And the standard deviation is 40.7. We want to know what percentage of men in this age range have a cholesterol level less than 239.15. So the first thing I'm going to do here before I actually start is I'm going to just draw a picture. So because this is normally distributed, I know that I'm going to have some sort of a bell-shaped curve here that represents my data set. And the center of our bell curve is always the mean, which is, we said 178.1 here. So again, your center is going to be your mean. Now, in this case, we're trying to figure out what percentage of men in this age range have cholesterol levels less than 239.15. So the first thing I'm going to do is I'm just going to figure out where 239.15 would go. So think about a regular number line, right? The larger numbers go on the right, smaller numbers go on the left, right? So if I was to kind of draw this out as more of a number line, let's say I have 178, I'd have 179, 180, 177, 176, etc. So this is really a number line here. We're just kind of putting a couple points on it. So that number 235 is much bigger than 178. So it could maybe be somewhere like right here. And it doesn't have to be perfect. This picture is really just for us to kind of visualize what's going on. And we want values that are less than 239. So really what we're looking at here is we're saying, okay, here's my cutoff, and I want all values smaller than this. Right, because we're looking for all values less than this. So this is what the visual looks like. We're kind of saying, okay, well, what's this region right here of my graph? If my data looks like a normal curve, I want to know, well, what's the percentage here? What's this represent? So your table will give that to you. So I'm going to go to my table on the first page. I'm going to find my z value that's associated with this x value. So that's the only thing, is our table only has z-scores, not x values. X values are your regular data sets. So we have to change to a z value first. So to find the z-score, you're going to take your data item. So here our data item is 239.15. You're going to subtract it with the mean, which is 178.1. And you do need to divide it by the standard deviation, which we're told is 40.7. All right, so when we do this, so I'm just moving my notes a little bit here, we're going to get 61.05 in the numerator, and we divide that by 40.7, we get 1.5. So in the table, the z-score we're going to look up is 1.5. All right, so basically this x value here relates to the z value of 1.5. Is kind of what we're saying. All right, so here's my table. I want 1.5. So here's my z-score of 1.5 right here. So my percentile, sorry, my percent is 93.32. So that means this area here is 93.32%. So what percent of men in this age range have cholesterol levels less than 239.15? Well, 93.32% of men. All right, let's try another one. So this one looks at lengths of pregnancies in women, and they are also normally distributed with a mean of 266 days and a standard deviation of 16 days. What percentage of children are born from pregnancies lasting more than 274 days? So before I read the note, again, I'm going to draw a picture here. So I'm going to start with my normal distribution. My center is my mean, which is going to be 266 days. And I'm looking for those that last more than 274. Well, 274 is bigger, so it's going to be like maybe right here. And this time I want values more than this. So I'm looking for this area here. Going this way. Now, just like before, I still have to start by finding my z value. So my data item is 274. My mean is 266. And my standard deviation is 16. So I'm going to go ahead and start with this here first. Sorry, I just got to get my notes. And when I subtract, I get 8 over 16, which is obviously 1/2 or 0.5. So your x value here is the same idea of having a z-score of 0.5. Now, with the table that I gave you, it always gives values less than or areas to the left. So when you're using this table, again, at the bottom is this key idea here that says it gives values for things that are less than, right? So it's giving area on the left. Here, I don't want less than, I want the greater than or the more than. So I want the opposite side. So when that happens, what you're going to do is you're going to still find your z-score in the table, but subtract it with 100%. Because the whole thing is 100%. So the table will give me the left side. I really want the right side. So I'm going to subtract with 100% here. So I'm going to find z is 0.05 first. Okay, and I can see it right here. So the percentile is 69.15. So what it's giving me is actually this part over here. So this part over here is 69.15%. So again, it's always area to the left on the table, but that's not what we want. So we're going to take 100%. We're going to subtract that 69.15%. And I get 30.85%. So this area right here is that 30.85% that we're looking for. So what percentage of children are born from pregnancies lasting more than 274 days? The answer is 30.85%. And let's do one last example. So this one says the amount of time that self-employed Americans work each week is normally distributed with a mean of 44.6 hours and a standard deviation of 14.4 hours. What percentage of self-employed individuals work between 37.4 and 80.6 hours per week? Now, again, before I get into the table, I'm going to draw that picture. So I know it's normal, so I'm going to have a bell shape. I know my mean is 44.6. This time I want values between 37.4 and 80.6. Now, 37.4 is smaller. 80.6 is bigger. It's going to be probably way over here. And this time we're looking for values in between. Okay, so I really want this area in here. Now, again, the table does not give that to me. It only gives me area to the left, or area less than. So what do you do if you're asked to find the area between two values? We find each z-score in the table and subtract the two percentages. That is the strategy. So I still need to find my z-scores. So we'll do x equals 80.6 first. So I get z equals 80.6 minus my mean over the 14.4. And then when I do the other one, I have 37.4 minus 44.6 over 14.4. And what I get here is negative 0.5. And here I get positive 2.5. So this value right here, the z-score, or the z-value, is going to be 2.5. And for this one, that z-value is negative 0.5. Now, just a little bit of notation. So your book will actually use subscripts here. So they'll actually write this as z sub 37.4 and z sub 80.6, just to kind of remind you what the x value was. So if you see that notation, that's all that means. All right, so I need 2% now. I need the 2.5 and I need the negative 0.5. So let me go back here. I'm gonna find the 2.5 first. See, that one is right here. So my percent for 2.5 is 99.38%. And then for negative 0.5, let's see, so it's right here. I get 30.85%. And then I'm going to go ahead and subtract these two values. And I get 68.53. So our answer here, what percentage of self-employed individuals in the US work between 37.4 and 80.6 hours per week? The answer is 68.53%. So again, just another little application that we can do with z-scores. So z-scores, and also even within them, that standard deviation has so many applications in statistics. This is just some of them. So this is from your text, and this just summarizes what we just did. So when you're looking at values less than, then you can just use the table to find the exact percentile that's given. If you're looking for values and your question is about something greater or more than, then don't forget you're going to subtract the value in the table with 100. And if you're looking for between two values, you're going to subtract the two table values for each of the z-scores. So you're going to find both z-values and subtract those two percentages. And that's how you can get all your calculations.